Let's see now some examples of derivatives of function. Here we have the function y, which is equal to minus x plus 3, which can also be seen as minus x to the power of 1 plus 3. So its derivative is minus 1, which multiplies x to the power of 1 minus 1, plus 0, because the gradient of the constant plus 3 is 0. And so the derivative of this function y is just minus 1, which is the final step of this exercise. Let's go to the next one. And we have the function y, which is equal to x to the power of 2 plus 1/2 multiplied by x. We apply again the rules 1 and 2 together, and we find that the derivative of y is 2 multiplied by x to the power of 2 minus 1 plus 1/2 multiplied by x to the power of 1 minus 1. And if we do the calculations, we find that this is equal to 2x plus 1/2. And this is the final derivative of the function y. The next function is y equal to 4x to the power of 4. We apply again the second rule, and we have that the derivative is equal to 4 multiplied by 4 multiplied by x to the power of 4 minus 1. And this is equal to 16x to the power of 3, which is the final answer. The next function is y equal to 3x to the power of 4 minus 10. Its function is 3 multiplied by 4 multiplied by x to the power of 4 minus 1 minus 0, because the derivative of a constant is 0. And since 3 multiplied by 4 is 12, x to the power of 4 minus 1 is x to the power of 3, so the final answer is 12x to the power of 3. Let's see the next exercise. The next function is y equal to 4x to the power of 2 minus 3x minus 7. So we have that the derivative of this function is y equal to 4 multiplied by 2 multiplied by x to the power of 2 minus 1 minus 3 multiplied by x to the power of 1 minus 1 plus 0. If we do all the calculations, we find that this derivative is equal to 8x minus 3, which is the final answer. Let's see again another example. This time we have the function 3x to the power of 4 plus 3x to the power of 3 plus 20x. The function is 3 multiplied by 4 multiplied by x to the power of 4 minus 1 plus 3 multiplied by 3 multiplied by x to the power of 2 minus 1 plus 20. And if we do all the calculations, we find that this is equal to 12x to the power of 3 plus 9x plus 20. And this is the final answer, the final derivative of the function y. Let's have a look to another example. This time we have a function which is made up of 3 terms that are multiplied to each other, and they are inside parentheses. We have the term x plus 1, the term x plus 2, and the term x plus 3. So as a first step, we do the multiplications between the first 2 terms, and we find that this is equal to x to the power of 2 plus 3x plus 2 that multiplies the third parenthesis x plus 3. In the next step, we do this other multiplication and we find all the terms. We rearrange them and we find that the function can be written as x to the power of 3 plus 6x to the power of 2 plus 11x plus 6. And then we multiply the rules of derivation and we find that the derivative of the function y is equal to 3x to the power of 3 minus 1 plus 6 multiplied by 2 multiplied by x to the power of 2 minus 1 plus 11 And this is equal to 3x to the power of 2 plus 12x plus 11. And this is the final derivative of this function. Let's now look at the final example. The function y this time is 5x to the power of 6 minus x to the power of 1/2. It's the first time that we find a fractional number in the power or in the exponent of x, but the rules are always the same. In fact, we have that the derivative of this function is 5 multiplied by 6 multiplied by x per 6 minus 1 minus 1/2 multiplied by x to the power of 1/2 minus 1. And if we do all the calculation, we find that this is equal to 30x to the power of 5 minus 1/2 x to the power of minus 1/2. And the minus 1/2 in the last exponent is because 1/2 minus 1 is equal to minus 1/2. And this is the final derivative of the function y.